A keynote for the day by David Gamba, Senior Director, Aerospace and Defense Vertical Marketing, Xilinx. Before I invite him on stage, a very brief introduction. David Gamba, like I mentioned, is Senior Director at Xilinx and leads the Aerospace and Defense Vertical Marketing team. David has spent 18 years in the FPGA industry and has been recognized by the industry for introducing hard floating point into FPGAs as well as the OpenCL programming language for FPGAs. Additionally, David has spent 5 years leading the sales and marketing organization for Aluros and assisting with sales and marketing activities for Hot Rail. Ladies and gentlemen, it is a privilege to have him here with us this morning. Please extend a warm welcome to David Gamba.
So thank you for coming out today. I'm really honored and humbled to see all of you in the audience today and to be part of this excitement that we're experiencing. Today I really want to talk about space. And one of the things I'm going to really focus on is the concept of intelligent electronics. And what better way to illustrate and talk about that than by celebrating the success of the Chandra 2 moon landing, right? This showed the world India's capability of being one of the foremost in technology, in space, and the ability to achieve what less than a handful of countries could achieve. Remarkable and very humbled to be part of this community. I'm also honored to be part of the Xilinx team that participated in this project. So we've had devices in the synthetic aperture radar which are going around and helping to monitor the poles for the different ice and water. In addition, we helped alleviate that 15 seconds of terror by having our devices involved in the lander module to really pick out a suitable area for the lander. Now, this is one of many projects that Xilinx has been involved with for space. And we have a rich heritage of supporting ISRO and the Indian community in space projects. And I'm very pleased that we're going to continue doing this. We are involved in multiple projects with ISRO. Many of them I cannot talk about here. I wish I could, but I can't. And we're going to continue to push our technology and introduce products and capabilities to make ISRO and the space community a tremendous success. Part of our non-ISRO heritage, non-India heritage, shown here with our Vertex 5 surf devices, which are a radiation-hardened device that has been in production nearly a decade and has heritage among over 100 missions. And we're able to offer devices that support synthetic aperture radar as well as altimeters, but also image processing, digital signal processing, communications. And one of the projects we're also very happy with is that we're on this OSIRIS-REx. So we helped land it on the asteroid and collect the samples and know those samples are coming back to Earth. So what we're seeing is actually the dawn of a new age. And this graphic here is showing that the traditional approach of government funding space projects, while it continues, does not stand in isolation in supporting the space exploration. We're actually seeing the commercial community start offering funding. We're showing here $18 billion that the commercial community is putting in addition to the government funding, to really drive space technology forward. Both the government activities and the commercial activities are going to benefit from this symbiotic relationship that they have. So this is what's very exciting. And what we're seeing is the dawn of what is called new space. Some may call it Space 2.0, may call it commercial space, commercial constellations, but not in the traditional geosynchronous orbits, but in LEO and new space orbits, we're seeing a tremendous amount of new entrants launching satellites. Companies we didn't hear of 10, even 5 years ago are now doing commercial launches. And they're being enabled by the foundation that ISRO and the space community and the rest of the world have put in place by making the technology available and then the efforts to increase the capabilities to reduce the launch costs, to reuse launchers, to really enable this new application space. And so some of the benefits that you're going to see is a lot more satellites out there. We're seeing it's a big race to be first, to really set up the constellations, the networks, the communications, and those are going to drive the cost down and increase the services and capabilities that we receive here on Earth. So this is a tremendous event. We're at a point in time that is unparalleled in history. So when I do a dichotomy of what we call the traditional space, and this is the government or the military programs, they're using space-grade devices, which really have to understand all the radiation environmental effects for deep space. The volumes are not very high, and the mission durations are 10 to 15 years. This is actually in distinct contrast to what we see in new space. What has been a surprise to me, and a surprise to many at Xilinx, the company, and even the semiconductor community as a whole, is these companies in new space are taking commercial-grade devices and flying them. What they're doing is they're really accelerating this technology deployment. There's been a lot of questions about how they will be serviceable up there, how will they be successful. This is a big risk, but this is what makes it so fun. This is what makes it so exciting. This is why I say this is a moment in time for all of us, where we see the innovation in the forefront starting to really leverage commercial capabilities into these space applications. But I do say that both will coexist. I see a distinct dichotomy between the traditional space and the missions, new space and the missions, coexisting, but having that mutually beneficial, symbiotic relationship of driving technology, driving costs down, and enabling new capabilities that we never even dreamed of. So there's a lot of news about new space. You know, SpaceX was mentioned earlier in the keynote, and they're launching a lot of satellites, and they expect to deploy those by late 2020. It is a race. They're moving very fast. Hot on their heels is Amazon as well. I don't know if many of you are familiar with the geography, but Amazon is very close to SpaceX. And actually, they swap employees back and forth. So they are in a very competitive race between the two companies to launch these constellations and get them up in service. In addition, Facebook, in partnership with Hughes, is launching a service as well to enable Wi-Fi hotspots in Colombia. And Virgin Galactic, Richard Branson's company, is looking to basically take passengers on the space flights. Now, I really enjoy stories like this, and in conjunction with working with our partners at Avnet and Spurd, DTDS, and Centrum, we're actually working with a lot of the Indian companies too, some startups in the new space area. Unfortunately, due to NDA restrictions, I can't talk about what we're doing there, but I really hope to come back in 2 years and talk about similar successes like this with the India community as well. I look forward to that. But what's interesting is some of the names up there represent a few of the 2,000 plus billionaires we have in this world. And there's actually been a study that 5% of those 2,000 billionaires, either passively or actively, are involved in space. And so this is what's created a term for me called the battle of the billionaires. And so what they're doing is they're using their tremendous wealth to really drive innovation in the space community, whether it's to offer commercial flights up to space, like Richard Branson's trying to do with Virgin Galactic, or Jeff Bezos wants to go to the moon. And I think many of you know Elon Musk's goal, which I believe he will achieve, is he wants to get us to Mars and colonize Mars. This is why, again, I say this is a moment in time. The amount of innovation that has been driven in the space community, the amount of coverage that you're starting to get on TV, the periodicals. I mean, these launches are being broadcast live. We're watching these live. And there's so much interest that this has really been a reinvigoration of the interest level I see for space. So the trends we're seeing is you really want to do as much as you can up in space. You want to have those capabilities and not have to go back down to terrestrial mission control systems, stations, to implement the capabilities. So digital processing, you want to do the signal processing, you want to do the signal manipulation in orbit if you can. There's a lot of cameras and videos, equipment on these spacecraft. You want to do that imagery, the recognition, the manipulation up in space if you can. And a machine learning, this is ubiquitous now. Why not do it in space as well? So there's been a huge push to enable machine learning in space. And so I'm really happy to say that all these trends that programmable logic and Xilinx are playing a part in helping support and make these successful. For example, for machine learning in space, want to really do image recognition. You have very expensive cameras up there. The last thing you want to see coming back down to mission control station is a bunch of clouds. It's not a very good use of that satellite link. So we're showing a machine learning demo outside today at our booth. That same technology and capability can be used in space to identify things like cloud and make sure that this is not what gets sent back to mission control, but actually the images of interest are what gets transmitted back down. This is some of the key innovations that you're taking the terrestrial technology and making it applicable in space and really making a more successful and beneficial experience. The other thing that we're seeing is around communications is, again, you want to do more of the manipulation up in space. And when they're putting together all these constellations to drive communications networks, there has to be some way to do the manipulation and the processing in the satellite. And that's what our devices are being used for. This is showing a simple example of doing a regenerative transponder. We actually do reprioritization of the communications up in the satellite. You do not need to come down to the ground station to do that. Saves a lot of time, saves a lot of latency, saves a lot of cost. And this is what's making this available to the masses. So what is it about Xilinx and programmable logic that is so beneficial in space? You know, why are we being used so much in traditional space and new space? Well, the reason is in a space environment is very constrained. And so you want to have as small a footprint as possible up in space. In addition, it's very power constrained. So you want to do the best you can to remove as much power as you can from your system. So what I have here is a little bit of a history on programmable logic for FPGAs. So we start with a simple programmable logic device back in, say, 1990s. And we'd have all these external components around them, memory, SerDes, RF capabilities, vector processors, DSP. Those would all be external to our device. And then over time, we started integrating these capabilities. First, the block memory in the late 1990s. In the early 2000s, we started bringing in DSP capabilities, removing components from the board into a single device, lowering power, lowering the size. But why stop here? We kept on going. We integrated the SerDes in the mid-2000s. Then we started integrating a processor, application-based processor, integrated a real-time processor, integrated gigasample per second RF capabilities in our latest generation of devices that are shipping in production. And I'll tell you, this device right now is in orbit with gigasample per second, DACs, and ADCs. The only company to be shipping this in programmable logic and monolithically today. Can't say who, but it's up there. The next step is going to be for vector processors. And the whole idea, you see, we're really taking that footprint and compressing it down into a very small, highly capable device, which by removing all those interfaces really helps drive the power down. The other aspect is these are standard products. So we help reduce the risk. You're not doing an ASIC tape out, for instance, and taking on all that risk yourself. You can buy these products today put the designs on them very quickly, keep changing the design all the way up to launch, and even after you launch and you're in orbit, do remote updates. And that is one of the key value proposition that Xilinx brings to the space community is unlimited on-orbit reconfigurations. Now, in some cases, this is planned. We've seen customers who swap algorithms, swap waveforms after the device has been launched. In other cases, this is unplanned. And I often say that using programmable logic in space is the best insurance policy money can buy. Because we've had customers launch satellites, have an issue. One was around the area of a communication system. Identify the problem in the satellite. It wasn't our device, honest. But reconfigured our device remotely from mission control on Earth to work around the challenge and fix the communication link. This is how this on-orbit reconfiguration is a tremendous value proposition and really is going to help drive space community as well as things like machine learning, digital signal processing, that adaptability that you have a benefit of here on Earth in space as well. So one of our partner companies I could talk about publicly, Fraunhofer in Germany, is actually using this reconfigurability as part of their key element of their space application. They were launching a communication satellite, the Heinrich Hertz communication satellite. It'll be going up in 2021. It's for medical studies, and what they're going to be doing is occasionally changing the waveform and the payload application from space. And they're going to do that using our FPGA, and they're going to communicate up using the link that's going to go into the ADC, and they're going to update remotely the algorithm or the waveform as needed. What they will get from this is a tremendous use out of their satellites, and one satellite can be used in a lot of different applications. This flexibility, again, is driving new capabilities that heretofore have not been seen in the space community, but also that element of cost, really helping drive that cost down. And we talked about earlier today how cost can be very critical in these applications, right? There's not an unlimited supply of money. And this technology is really helping to drive costs way down. So Xilinx is very proud of our heritage. We're very honored to be part of the Chandrayaan-2 satellite mission. We're very honored to be part of other Israel and other missions as well. And we're going to continue investing with our space devices. Whether it's for traditional space, we're going to be introducing our next generation space device sampling end of this year. And I know there's a lot of demand for that. But we're also going to continue to introduce monolithic devices for use in space, whether it's the multiprocessor system on a chip or the RF system on a chip that's being used today. We'll continue to drive these roadmaps with our devices. We'll continue to support the radiation testing that is required, that is expected of us being a part of the space community. And we'll continue to support all the radiation test consortiums and our customer needs and making sure that they could use the Xilinx devices reliability with very high quality and take the full advantage of that key value proposition of the processing capabilities with that on-orbit reconfiguration to do things like the communication satellites, the machine learnings, the application swapping, and even the occasional bug fixes. So with that, I want to say thank you for inviting Xilinx. We're very proud to be a gold sponsor today. We're very pleased that the success that Israel and the space community is having here in India. When I travel to other countries, to be frank, they're asking me, how does India do it? And I really don't have the answer for that, but I will say that the prowess that many of you in this room and others who are not here with us today have raised the stature of India's space program tremendously, and it has been recognized throughout the world. Thank you.
Ladies and gentlemen, can we have a big round of applause once again for David Gamba for that keynote address? I'd like to request Anil Kumar from Iesa to present a small token of our appreciation to David. David Gamba, ladies and gentlemen, Senior Director, Aerospace and Defense Vertical Marketing from Xilinx. I'd like to thank him once again for that keynote address. I'd like to thank Anil as well for stepping in and presenting that memento. Thank you very much indeed. Speaker, Mr. Gulshan Rai, retired former National Cybersecurity Coordinator, Prime Minister's Office, Government of India. Since 1998, Mr. Rai has been working in the area of evolving legal frameworks to address issues arising out of cyberspace and several related fields. He was the Chief Information Security Officer, Prime Minister's Office. He also served as the Director General, CRT in Indian Computer Emergency Response Team and Group Coordinator of E-Security and Cyber Law Division in the Ministry of Communications and Information Technology earlier. Ladies and gentlemen, please extend a warm welcome this morning to Mr. Gulshan Rai.
My esteemed friends, Venki, the Chairman of Iesa, Mr. Jitendra Chadda, Ms. Reena Raman, Vice President and General Manager, Intel, Mr. Thierry Martin, the Vice President and T-Connect, Mr. David Gamba, Senior Director, Xilinx, distinguished delegates, friends, ladies and gentlemen, good afternoon to all of you. I am delighted to be here once again in this. I came about a year before last year and interacted with many young scientists, young developers, young engineers, and the companies, startup companies there. So it's a pleasure and a privilege to be here again, and I thank particularly Venki and the IESA for once again giving me opportunity to come and interact. Friends, I'm not going to go detail in the technology, which you're going to have a different sessions, but I will take up slightly different perspective on the technology related issues which are coming up, and directly or indirectly it impacts the industry, common person, society, and the government as a country as a whole. All of you know that the country has put a target of a $5 trillion digital economy by the year 2024. That's the target which Honorable Prime Minister has said, and the country has accepted the target. There are views whether we achieve, we are not achieve. We are at $2.7374 trillion. We will not be able to achieve with this slightly economic slowdown. There are issues there. But leaving apart those issues, one thing has been agreed, and there is no dispute, that the components of this digital transformation which we have seen past 10 years, they will undergo a rapid transformation, integration in the next 5 years, minimum 5 years. The basic technologies of web, mobile, virtual reality, all kind of a SMA, which we have seen, where we saw the industry 3.0, will be only the somewhat underlying component there. But these underlying component will be used to create used to another components to reach to that kind of a economic factor, digital economy. Digitization is increasing. I was outside in a stall which is dealing with the connectors there, and the connectivity is increasing. The the principle which is going to come up is the sensing, connectivity, and moving people. You call it moving people or call it mobility. That is the theme and a motto of the next 2 decade to meet up years is going to be there. Those transformation component which all of you know, we talk about the AI or the ML or the IoT or the cloud or the blockchain, some people may say, the 5G, next generation communication technology, analytics, big data, those are the components which everyone talk about it. But these components will get implemented in a different manner across the sector of economies, whether it's a defense, civilian sector, education, industry, anything, it will get implemented in a different manner there. This will give rise to issues, many issues there. The first issue is that we will be needing a altogether different product and different services. That's what it will give rise to that in next 5 years. And the country has to prepare itself, because we have set a target of $5 trillion by 2024. Means by the time we have a next general election, we will be a country with altogether different transformation. That's what we have taken upon ourselves to do that. And we will need all those kind of issues which have arisen, and we need to address those issues. If you look at the innovation dimension, the dimensions of the innovations or the dimensions of the digital economy or digitization which we are going to face it. The first dimension is going to be the talent. The second dimension is going to be a infrastructure, super infrastructure, or you may call infrastructure. The third dimension is going to be your industrial environment. And the fourth dimension is going to be your next generation communication, Wi-Fi. The last component of the next generation innovation is the area to be focused there. And that last area is a debatable area, and on which many of us fall down, whether we should go core area, we should spread out our area, we are doing services, we get into the product. Those are the issues gets in the last area, but it's very important issue. All of them are a issue which are important, and they're connected together, they complement each other. Unlike the previous decade or maybe 15 years, we are not going to see a technology embedded into our system, in our life, standalone technology. It will be convergence of technology. Mutual aspects will be there. And that is the experience, you can see that. Talk about anything, Fitbit, LED TV, LCD TV, you are see that small big data, small AI is already empowered there. And the kind of innovations which are happening there, you get mind-boggling. By the time you come back after visiting first time, discussing with them, next time you go back, you find it altogether different kind of a scenario there. Different ideas, different innovations, young people are beaming with the ideas and trying to do that. That may be a asset there, but then it has a different aspect also there. So these component of the entire innovation, called the dimension of the innovation, is going to play a bigger role in the next couple of years if we have to catch up economy, or maybe a world. These are the issues, maybe a smaller or bigger issue and worldwide also there. Talent is a issue. The present talent which is available need to be upgraded in terms of skills to handle it. India has more than 170 data centers, recognized data centers. But when we talk about the data center, we talk about Amazon, Google, or the Microsoft cloud. communication story, you know, we all struggle in the 4G, and we are talking about a 5G in another 2 years' time. World also realizes the issues which next generation communication has to come up. And that's why we are talking about a 4G plus. We are not implementing 5G at right now. All implementation is kind of a 4G plus. We are making a standard architecture of the 5G compatible to the existing architecture of the 4G, and that's what we are trying to address that. Taking connectivity to rural areas there. So whole this aspect of a cloud, which is a very one of the essential component of Industry 4.0, is certainly an a matter which need to be addressed. And then your focus area, which slightly I have discussed. Now, if you look at the impact of this, which we have already started seeing, that we have some more than 26,000 startup. And that itself is again a disruption, another business transformation there. Unicorn, Decacorn, all kind of a startup has come. 26,000 odd startups are there. Many of you who are present here doing wonderful job to do that. But then we need to, first of all, the larger issue with India is that we need to not regulate them. We need to channelize them or guide them to go for the priority of the country where we require the product there, where we require to do that. That's one challenge which we need to sit down collectively and address that. 80% of the startup, they are struggling. They are not able to fulfill those objectives with which they started the company. The rest of the 20%, 10% only are able to go through, because 10% they start doing that, spend couple of time, but they are not able to sustain beyond certain period in terms of product, future development, or the taking the product to its further maturity. I mean, there are geopolitical issues and all other things are there. So there are complications which are coming up in our further march of boosting our economy. If you see the startup sector also, where is the larger investment is coming there? The larger investment is coming on the product which interacts with the citizen. Larger investment, where the citizen interface is there. They want to collect the data, reach to the citizen, collect the data for variety of purposes, maybe to mature, to sustain their revenue model, to sustain their development, because you require a data to further develop the product or mature a product or tune the product. That is where the larger money is coming, primarily from the investor outside the country. We had some $4 billion investment from Japan, about $3 billion investment from USA, significant investment from China, another significant investment from Singapore, and we have some investment from the UK also, but not largely from the other European country, largely from UK. That's our ecosystem comes up there. Now, if we have to sustain our goal, whatever we have set for ourselves, the survival, the growth of the startup sector is the part of a so-called SDG, Sustainable Development Goal. That is a part of that. And that is, I think, we need to debate more, and we need to really see what can we do. One part is the technical, other part is the regulation, and the third part is the internal kind of a things. And I would request, if you can debate, and if you can tell if some initiative can be taken by IESA or anyone else, where if facilities are set up or the skilling of the people so that we get the best talent to do that. I was struggling for 3 years to get a proposal from an educational institution to start a training programs, skilling program, 4 weeks, 3 weeks, 6 months, 1 year, in different subjects there, because let the people get it better. And trying to bring a approachment between the industry and the education sector. I admit I could not succeed. But we cannot sustain the march or whatever investment has come up if we don't focus on the best talent which we get, because there will be a competition. There will be intense competition within the body and outside the body. These component transformation will go across, whether it is the defense or civil. The defense electronics itself will be totally impacted by these components which we discuss, Industry 4.0. So the talent is necessary. How do we proceed towards creating a talent at a reasonable cost? How do we bring the public-private partnership in this sector, but in general also? Because a $5 trillion economy, or whatever number we talk about it, it cannot come only from the public sectors or the large IT giants. It has to come from the larger public and private sector. Employment will have to come from there. The technology has to come from there. We have to tap it. So the first priority which I feel is how do we set up a public-private partnership, robust manner, where we train our people, get the best talent there. That's one aspect we need to do that. The second aspect of the public-private partnership we need to set up for the infrastructure. And that infrastructure, we are bogged down by several issues there. Localization issue, privacy issue, liability issues there. And then people are talking about the cyber insurance issues there. That itself requires a public-private partnership, because the regulation will be set up by the government, but in consultation with the practitioner, which are you people there. I was in Stanford University about 10 days ago, and I was talking to some people who are in the university professor, the cyber insurance, and I wanted to understand how much they have gone through in the cyber insurance things there. And I was stunned, because those issues were even in mind. How do you determine the liability? Insurance thing can be just swayed away, not because of your own fault, because of someone else's fault. And I think all of you have heard a very famous incident that some fellow was caught by the police. He was driving a car and he made an accident there. When he went to the court, he said, "Sir, I am not responsible, Lordship. My arm is an artificial arm, so I have no control over that. It's some electronics who was doing it. I have no control over there." So insurance is also like that. Now, how do I get the insurance? In this particular case also, how the insurance company gets up? I mean, ultimately that guy, what case goes on, he was acquitted there. It's a fault of the arm, which is artificial arm. So these issues are going to become up very, very important. So any development which we do as a startup, I think we need to look at these issues right in the beginning from day one. Rest assured, the world is going to think in a different manner. Absolutely different manner. And I was speaking therefore yesterday, and I quoted a thing long back. Entire world was upon China. Open market. And to us also open the market there. We opened the market. But today when 5G comes up, the issues have become so important that they want to shut down the country. That one aspect. I'm not getting into the security aspect there. One aspect there. So when we need to create our system in a manner that we should be able to withstand our geopolitical issues. These issues will become important, and these issues will certainly come in the way of our development. So sometime we need to move toward where we are able to stand. Yes, it is also true that we cannot develop entire thing in our one. We need to focus on core areas where I said the fifth component of the dimension of the innovation. So which are the core areas we focus so that we compete at the world level while taking care of those nuances which may arise either due to the legal or largely geopolitical issues. That's where we need to sit down and collectively do that. Maybe IESA can do, or something. I mean, I'm open to provide whatever help, assistance I have. I mean, it's all available to you as already, and we can certainly tap the resources in the country where things are there. And I give you one to news that I think today the notification issued by the Ministry of Corporate Affairs, where they set up a standing committee to look into the technological issues and other issues which may impact or influence the corporate governance. I think they are I saw the notification yesterday, and I think they are going to issue today notified there. That's what the notification date was, 19th. That's what things are happening. That's another part which startup will have to look into that aspect. And the third aspect, if you go to the Delta, that Netherlands technology park, or you go to the UK park, we have been to both of them, and that Baltimore kind of a park there. I think we need to look at creating those kind of a structures in the country. We cannot live purely on the startup. We need to create those structures. Those are part of the infrastructure structures that we need to create for to move for our unit, for us to move towards achieving ultimately the goal of creating new product, new services in another 2 years. That aspect which you need to create it. Friend, this Industry 4.0 will certainly be much more revolutionary than what we have seen. Major revolutionary changes will come in the computing system, whether it is a software, hardware, communication technology. I really cannot say, and I don't know how many of you can say with authority, what will be the scenario after 3 years. We can only talk qualitatively. We are not seeing the real impact of the 5G, how it will come, because they are not implemented. And we are, worldwide, we are 1 year away. India is minimum 2 years away. So there will be a revolutionary changes, revolutionary development will happen in the next decade in the entire ICT component, software, product, communication, hardware, entire thing. IoT's revolution will be different. We still have not seen I've seen some of the reports in Harvard and some other such universities there, but we yet to see what the understanding in the Indian scenario, the legal issues and the other security issues there. So friends, we are in that revolutionary. Then the next revolutionary things will happen when you talk about the sensor, because I said, in my view, the sensing, connectivity, and moving people is the next decade kind of a scenario vision going to happen. So next is the revolutionary changes will happen in the sensor, whether you talk about a chemical sensor or biological sensors or any kind of a sensor you talk about imager, because the cyber physical connectivity is going to happen, is the order of the day which we are going to see. We are moving toward self-healing, self-correcting, self-monitoring kind of a system, because the billions of devices getting connected on a heterogeneous devices on a network which is a 5G complete virtualization there, software virtualization, hardware virtualization, and your network virtualization with a slicing kind of a feature. So I think there is a need, and we'll be moving towards self-healing, self-correcting kind of a self-analysis kind of a system there. Now this heterogeneous connectivity will give rise to the issues which I have been dealing for the last almost 12 to 15 years is the security. And I mean, if I tell you the incident I have seen, as early as in January 2019 or February 2019, they are mind-boggling, and it is very difficult to detect who is responsible, who is trying to do that. BJP prefix hijacking. The entire traffic is getting hijacked. I identify the traffic of the mail traffic coming from Purnima or Mr. Venki and completely hijack it, pass through somewhere else. It is possible to do using this kind of a transformation component which I have mentioned today. So the security issues, the emerging trend which is now attack is totally different than what we have seen during the past 5 years. Spear phishing is the order of the day, and complicated spear phishing. You have those encrypting wall ransomware. Very complicated ransomware is coming then, and a lot of people are claiming that we have created a antidote to ransomware. Now imagine when you have a heterogeneous connectivity, a small device of a mobile phone, and it can impact ransomware getting into the entire network, what havoc it can create. And many of you, and maybe all of you, will be knowing the myriad attacks on the IoT botnets kind of attack you have seen. So that scenario will have to come up, and our challenge is that the product is created and security is created only after 2 years when we know the product or we understand the nuances of the product, because no one will declare what product he is going to make it there. So there is a dichotomy between that. Great challenge. We need to look at it, but I think we need to adopt in such a scenario, first of all, we need to choose what product we make it, what product will do, and look at the next couple of years, the product will be able to do what is to be done. It should not be like a BharatNet of the Department of Telecommunication, where they implemented GPON technology, and the GPON technology was obsolete at the time of its starting using it also there. We are talking about OTT and IP. If I have to make a call to you, I have to make a WhatsApp call or some call going outside Skype call, because we are not able to connect on a 4G. So we need to look at what product will be there in the next 3 years, what are the issues going to come up. That is where I think IESA will have to play a role, because startup will be find difficult to do that. We need to play a role to make that thing. Without, if we do that, I think success rate certainly will improve. The factor there. That is the security aspect which we'll see. And the last is the government and regulation, where we need to work today. Now I don't know how are we going to solve the issue of personal data and non-personal data. If you move on the network, it has to come from a device. And when we move toward the IPv6 version, it's all personal. IPv6, the IP address is allocated to me personal. The whole concept of a GDPR, they say the whose directory is not to be published there. It's personal there, and IP address, everything is personal there. Metadata is a personal there. So these government regulations, so my request to all of you is that, let me be candid and admit to you, the understanding in the government in this area need to be significantly improved, both in terms of technology and interfacing with the policy and regulation. That need to be improved. In fact, the entire government is more working on an outsourcing mode. Hire some big four people and start working that. And the big four people hire L1 route, and they have their own issues also there. So today, if we reach to if we want $5 trillion technology, we need a new product, new services, and we need to address all the 5 components which in my view are important to keep ourselves ahead or running into the digital race with the worldwide. Otherwise, issues will be totally different. If you look at the, let us say, 20 companies or 30 companies or maybe 100 companies in terms of market cap, IT companies of the world, you yourself know where the Indian companies are there. And if we don't keep ourselves race, we'll be go away. 200 odd fintech companies are there in India doing excellent work, but funded by outside. All IP goes outside, no problem. This is a global world, we need to look at it. But then we also need to see what do we learn from them and how do we put it in, how does it benefit to our ecosystem to do that. Friends, they are very, very complex issues, and the entire scenario which I see is going to change. I don't know, how do we address? My always question comes up, are we geared up? Are we ready to handle that? There are small, small nuances. We need a missionary approach to handle that. Complete missionary approach to handle that. And that is where Venki said 10 minutes. You said 10 minutes. So that's where I leave it, that kindly let me know how we can work together. I'm not going to ask, are we ready? The question is very clear, we are not ready. We are not anywhere near to what we are going to see. Things are there. And I also tell you, the scenario of Tencent or Huawei or Jetty, what they are in this scenario, in the world scenario today, may be a different scenario in the next 5 years there. I have seen companies getting innovated, disruption, the laggard and the followers. I have all seen that in my life, in this professional life for more than 25 years. We don't have to lose hope. We all have the potential, but I think we need to work together collectively and sort out the issues transparently among each other. And we need your suggestion, we need your cooperation. And anyway, my last point is that I am at your disposal. You please tell me where I can help you without any hesitation. I once again thank Iesa for inviting me, facilitating my visit here, and giving opportunity to talk to you, because throughout the day you will be talking different technology aspects. I'm not going to deal those technology aspects, bore you there, because my credibility is more in different area, but to operational area also. That's where I end it. Thanks very much.
Thank you very much indeed, Dr. Gulshan Rai. I'd like to request Purnima Shenoy, co-founder and CEO of the game, to present Dr. Gulshan Rai with a small
Before that,
token.
if there are any question, I'm willing to answer those questions.
All right. Ladies and gentlemen, if you have any questions, if you can just raise your hand, we'll make sure mic reaches you.
You have to identify your name so that I know that. In fact, I brought a presentation. Venki said 10 minutes, so I kept the presentation with me. He told me, last time when I left Delhi, he said, you have 40 minutes. Now when I reached here, he said 10 minutes. So I brought the pen drive and kept in my pocket. That's so I can hear you. Sorry, Venki.
Point is this, if we want security, we have to pay for it. And it has to be on different grades. Grades means grade 1, grade 2, grade 3. You can define the grades and have a cost associated with that. Why I am saying so is, in defense we follow certain procedures. You might have heard of that one-time authentication sheet. That is the highest security you have. That means one word is given, x-axis, y-axis, we just send that coordinates, and that word is cut. Thereafter it is not repeated. So only once it is used. So it has got the highest security. Whereas we have cipher people working on various public keys, private keys and things like that, and which has got different security levels of 24 hours, 12 hours, 8 hours, 4 hours, like that. Now, if you want to incorporate such security features in civil, a team has to be dedicated for that, and it has to work on it continuously, and it has to beat the competitor, because competitor is possibly the hacker, and hackers have to be beaten. So it is not that very easy. It is a very costly proposition. So are we ready to meet the cost for it?
No, I'll answer. I have a slide. I will show you. You see, what you talk about, unfortunately, you are giving a lot of credit to defense security, and you are coming from the physical background. You are more or less, your thoughts are coming from physical background. In terms of cyber kind of things, whether it's a civilian or defense, they're almost at the same stage. I didn't know I don't know from which organization you are. Huh?
Signals
there. See, you are a user. You are not developer of a product. And less said the better. let's set the better in this forum there. Where are signals and where are the product? I have complete understanding part of it there. So when you talk about the security, that's why I was taking out this. I have one slide to answer your point. What are the issues which you have? And you tell me whether signals is doing or signal is not doing it. There are responsibility on the product OEM, but there are responsibility on the signals also there. I will explain. If somebody can help me to put wherever I have to put it, one slide I will take and show to you. The concept which are there and the concept which are going on there. So, I mean, before, by the time if they are able to put it, you see, what is the security kind of a structure in this country? There are CISO, there are CIOs. First of all, there is a problem in the who is CISO and who is CIO, one or two. Okay, the CISO creates a security enterprise structure which is more enterprise level there. Okay. What is the concept? He puts a firewalls, he puts a IPS device there and try to put that kind of a CISO architecture, and always there is a difference between CIO and CISO there in all organizations in the country and abroad also there. Now that enterprise architecture, will it be valid with the scenario which we are talking about distributed there? You look at your signals also, will it be valid there? And I will give you the scenario if someone puts that. What scenario there, you tell me whether you follow in signals. Forget about, I mean, I don't want to give credit or discredit to anyone. I was also responsible, I'm still responsible for that. The scenario is different there. Security architecture is going to be completely different. Completely different. Are they going to put it? There is file name Intel and there is a, you can see how do I get it? Intel file name Intel is there, and then there are some, just browse the slides, I will say you stop it somewhere. I'll tell you what is the, I mean, where we need to go through that. Go further. Go down. Put this slide, 21. See, now look at it. Actually, the system should be that you design the architecture, and then the architecture must be signed by some fellow who understands security and the ecosystem there. Okay. Then the second point is that architecture should be implemented. Again, vetted by someone after the implementation, by CISO or CIO or whosoever is concerned that. The security review need to be taken there. Then you go into the code review. Okay. The code review is not most of the time which we do on a block basis, input and output. Okay. The code review. Then you go to the testing part of the things there, and the last one deployment, and then do the enterprise testing. That's a security cycle. Now you answer me, do you follow in signals?
Yeah, I can understand that. But
No, you have admitted what I want to say. You understand that.
We follow in core signals. We follow meticulously, security measures, and
that's why
physical
security.
I
can bet anything if you do follow this testing or this code review.
No. Testing is also done, not by the user. There is a cipher department in Delhi.
My dear friend, it's not possible. No software code is less than 500,000 lines there.
Yeah, okay.
Today.
Okay.
It's not possible to do that. No code is less than 500,000 code.
We'll take it off.
I think you have gone to the point. I have gone in deeper inside that. My whole life is spent. You tell me I will come out with everything. It's not like that. So this is structure we need to follow. And this structure is going to be more important when we are going to have a heterogeneous connectivity, multiple things are there, embedded devices are there. You have put the UPI interface. FinTech, we are talking about the FinTech. UPI is interacting with, you don't know other side what is being interacted there. So there are issues of process, there are issues of technology, there are issues of the entire system framework need to be set up. Bank A need to follow what the NPCI does it, what NPCI has to follow what they have to do that. There are the big challenges which have come up, and these challenges are going to go up. More and more challenges are going to come up there.
Thank you.
Yes.
Excuse me, sir. My question actually is related to Chandrayaan 2. So, since we're talking about security, do we see any, international, some kind of a conspiracy behind not being able to communicate with, the lander? In the last few, minutes, it's something very surprising that, having gone that far, losing communication just about 2 kilometers from.
I'm not able to see the gentleman because of the light kind of things there. Who's
Here.
the light is coming?
So as long as the
Okay,
question reached
I'm
you.
able to, I can see now. Yes,
Yeah,
sir.
sure.
Yes.
So, is there some international kind of a conspiracy behind this that we are not able to actually having gone that far, millions of kilometers, not being able to do the last 2 kilometers? Do we really see anything, so security lapse and anything that has probably happened around?
I think you have the right people in this forum in the morning. You should have asked this question addressed to them.
No, since we're talking about security also, I thought.
I am not the right. I was not there. That is not a cyber security. Okay. Again,
it's
there's a cyber.
it's a communication.
No, it's a cyber physical system part is there.
It's a communication.
Cyber physical system, but I think the people who are there, you should have addressed the question to them. I'm not able to address your question. I wish.
All right, ladies and gentlemen, due to the paucity of time, we'll have to stop with that last question. Please give Dr. Gulshan Rai a big round of applause. We'd like to thank him for that very interactive session. I'd like to request Purnima Shenoy, co-founder and CEO of The Gain, to present Dr. Gulshan Rai with a small token of our appreciation on behalf of Iesa. Dr. Gulshan Rai, thank you once again. Thank you very much. All right, ladies and gentlemen, we are slightly behind schedule, so I'm going to request all of you to please be back in the hall in 45 minutes from now. Lunch is being served. We'll start with the next session 45 minutes from now. We'd also like to remind you that we have the ISRO Mobile Museum on display for both days of the event. We'd like to encourage you, whenever you have the time, to please visit the ISRO Mobile Museum. We also have an Iesa backdrop at the courtyard. We'd like to encourage you to please take selfies and tweet it, hashtag Deftronics or hashtag Spacetronic, the handle at the rate of Iesa Online. Welcome back, ladies and gentlemen, to this post-lunch ISRO session. We'll have two topics being addressed and discussed: mission pipeline of future projects and 6 to 12 launch challenge, the roadmap ahead. To take this session forward, I'd like to invite on stage Mr. Prasanna, Deputy Director, CBPO ISRO. I'd like to request him to please come forward and carry this session forward.
Good afternoon, everybody. I welcome all of you for technical session now. A series of speakers from ISRO and major industry partners of ISRO are presenting now. I request all the presenters to limit their presentation within 10 minutes. Now I request Mr. Sudhir to present from CBPO. He is Associate Director, Capacity Building Program Office from ISRO headquarters.
Very good afternoon, friends, ladies and gentlemen. Maybe after lunch, I hope you are comfortable to listen. Electronics is a dynamic field. Everybody should find more interesting rather than a normal academic presentations. I would try to make it more comfortable as possible to you after this lunch session. Space, the thanks for giving opportunity, the Iesa, to be with you and to share some of my experiences and agony and rather zeal to be with you, to make you to be part of the space program. I do not know at the end of the day or end of the session how many of you who show more interest to be part with us. This all depends on the space sector, what you call commercially, definitely will not meet the fundamental principles of your business and accountancy. Why? Because everybody sees that profit analysis, break-even analysis, ROI, whatever you call it as. But unfortunately, the space is not the area where such kind of principles will meet. And I urge all the people over here to be more patriotic and to be more passionate to be part of the space program. Otherwise, the space program is no longer an attractive business for anybody. But if you are interested, if you are a technology savvy, once you enter, it is like a narrow gate. And inside, you cannot imagine how wide the industry is. Once you enter, you should not go back looking at the gate. Once you enter into the gate, you will feel really you are fortunate to work with your own space systems. There is only to that humble beginning. I just rushed through some of the, it is not a presentation, I don't call it as a presentation. It is more like a motivation teaser. I don't find much details I'm going to talk about, but probably I may create some kind of interest. If that interest creates some kind of a big angry, they are not angry, hungry in you, that probably that hungry will take you, the mother necessity is the mother of invention, to be with us in the future to come. We will help you in all respects. One thing is, it is not a general thing which is openable for everybody to read and to note. Lot of hidden things will be there. Unless you sit with us in a respective, in a particular area and try to understand and customize your requirements to suit to our requirement, it is not possible in this area to note. And second thing is, you are not dealing with customers, maybe online shopping, such kind of things. You are dealing with scientists. Scientists are hard nuts. They will never get satisfied. They are all perfectionists. Lot of changes will be there. The requirements would be, these are all the things which I am explaining you. Maybe in my journey when I am discussing with several people, we start with one RFP, ultimately ends up with maybe 20 to 30% of modification, because the demands, the technology demands, the obsolescence demands, the requirements as such, when we are meeting and discussing with you, the requirements itself may change. So these are all the difficulties in space industry. Of course, not only space industry, any technology industry. So people should not get perturbed. People should not talk about, no, we have already signed the contract, I cannot deviate from the thing, my estimations are wrong. Commercial aspects can be dealt in a different way, but understanding the technology, meeting the user requirements, meeting the ultimate goal should be the passion of any industry. You call it as major industries, medium industries, MSMEs, startups, everybody has got a role, very vital role to play, as long as you understand the requirement. So my, here maybe another 10 minutes, my intention is to make you to understand, to create a zeal or to create an interest, to further dwell on. Please bore us, please torture us, we never mind, but we want good partners, not even vendors, partners. With that, I'll start my presentation. If you see the space, what we talk about, the space applications are one side, Earth observations, communication, navigation, and interplanetary missions. These are all the ultimate goals of a national space agency. At the same time, the agency, National Space Agency has to work on launch vehicles building, satellite building, and ultimate user requirements like software and hardware. And ISRO will take the lead in managing the resources and industry to meet this entire framework. The ISRO is committed now, the agenda could be acquiring the critical technologies, because we have already done the productionization of very robust vehicles like PSLV. Ultimately, we want to hand over the PSLV industry to the industry. This is one move. Very recently, you would have seen, many of you would have seen in the newspapers stating that ISRO has opened up the gates for the industrialization or productionization, where you fit in, whether tier 2 or tier 3, you have to choose yourself. But of course, the ROI is on, and consortium partners have been invited through an EOA process. This process is going to be on in a couple of weeks. Probably you will have, if at all you are in a productionization environment, you will find more space and more room for you to supply some of the items which have already invented. But coming to the interplanetary explorations, a lot of imagination, even you call it as what kind of interplanetary imaginations today. If I wanted to present my thought to the public forum, a small startup can sit with me, understand the requirements, and make a beautiful animation. You just see how the requirements will come into. We are moving towards interplanetary explorations. We want to be self-reliance on all, both launch vehicle technology as well as satellite technology. If you see the import component of any satellite building, it would be as high as 50%. As high as 50%. The basic components we don't have. Everybody sitting here, they know the reasons behind it. And self-reliance in space transportation is a very, very important thing. Already government has announced a very beautiful electronic policy 2019, and Prime Minister, he himself is making a big show, Make in India program. How we make the India great, it is in your hands. See that the legacy of the launch vehicle development, if you see 1963, we started with a humble Niki Apache which was imported from America, and ultimately we are moving to GSLV Mark III, which is 4,000 ton class vehicle. Even the first vehicle itself was made success. So please try to understand the agony and the hard work what we people put in to make the projects effective, with of course your cooperation. In the satellite technology, these are all some ambitious missions ISRO has got, like recoverable re-entry technologies, 2-stage to orbit, and with the different variants, bringing the 10-ton class payloads to the low Earth orbits and medium Earth orbits. These are all the projects going on, but for all these things, a huge support, including Gaganyaan, we expect from the industry. If you take the satellite front, which of course is the slide which is most important and informative to you people, being the electronic industry, though slowly we are moving from a conventional panachromatic and multispectral technology to microwaves, detectors, and DDA devices, even with sensors, very sophisticated systems. On the other side, platforms to high loss platforms, high resolution, high power K-band transponders. We are moving towards this phase. Probably in these areas, if some of the people you have, let us say, collaborations with foreign companies, you can, maybe these technologies are going to come in couple of years or maybe within a decade to come. You can have plans right now to have an niche in the space front. Already NAVIC is announced, a beautiful navigation system, but even though it is a regional navigation system, it is quite useful for the Indians to start with. The NAVIC processor and propagating the NAVIC resources and applications is a huge responsibility on every one of us. If you start a mobile, unless GPS, you can't work in a city right now. If you want to locate something, yes. You make Gagan, our NAVIC just replaces the sophisticated software what you have. Many startups who are there, they do find a lot of interest in this regional navigation system or NAVIC. Gaganyaan. Gaganyaan is one challenge Prime Minister has thrown to ISRO to complete it within maximum of 4 years to put the man into the orbit. We are struggling to reach the technologies. Somewhere we are hiring, somewhere we are adopting, somewhere we are developing. But electronics is an area which should definitely fill the gap between the requirement and the need, availability and the need. These are all the different technologies that we are looking for developing, completing the Gaganyaan project. Coming to some of the statistics, let's say when you come to what is the opportunities of a business in volumes. The budget of ISRO is growing, and this year, including the projects, it is almost, you can say, in the last 5 years itself, it is almost increased by 1.5 times to 2 times. It is going further up. In this, 20% I should think that it contributes to satellite development. And in the 20%, you take 125 crores for the current year, you take 250 crores. In the 250 crores, even if you take the procurement activity, even if it is, let us say, 50%, you just imagine what is the kind of volume that opportunity is available for industry to help us. And it is not so. The budgets are only up to this year. You can say 18-19 or 19-20. But there was a demand from international users to increase our capability by double. You just imagine. Because we don't have because capacity building, now we are concerned for I am now working in a capacity building. Every capacity building has a gestation period. We are in that transition. The moment the capacity has been built to meet 12 launches per year, this is going to happen. You just imagine what is the volume of work. If we take again the indigenization, what is the import component of various materials? 39% is electronics and instrumentation. See, coming to the basics of the let's say space electronics, I call it as, the majority of the classification, what I feel, I have done it, maybe some reclassification could be there. It is my perspective. There could be avionics, which are basically up in the air, ground systems and infrastructure. Everybody talks of satellite. For making one satellite, how much infrastructure that is required? You just imagine. The infrastructure could be the production setups where process automation is there. You have to maintain those softwares. Every 5-year replacement will be there, either on account of obsolescence or on account of any reason. Electronics is more for such kind of obsolescence, everybody knows it. And if you produce one satellite, the cost of infrastructure could be multiples of tens or even multiples of hundreds. Similarly, because being it's an explosive industry, not even explosive industry, is a high class explosive industry, everything has to be done on remote basis. In that remote basis operation itself, you imagine how many sensors, how many communication systems, how many CCTV systems, how many surveillance systems on an every regular year basis, how many data acquisition systems, data monitoring systems, how many such systems are there? Because everybody talks of, I want to build a satellite, I want to be part of satellite program. Forget about satellite, because satellite is our niche area. That is second step. First you have to cross means you have to pass out 10th class first. After that only you will get into intermediate, after that only BTech. Please touch all these areas. Please improve your participation. Then slowly understand our systems. If once you get into our shoes, you will understand our requirements and you will appreciate better. First is entering into the gate, that's what I told. These are all the areas where you can enter into the gate, so that you will have an access control, access card. With that one, you can try to understand our requirements more better. Very high sophisticated systems are there, ground testing equipment. Ground system equipment, huge infrastructure, both at SHAR, both at IPRC, VSSC, ISTRAC, ISAC, everywhere. These infrastructure operation and maintenance cause huge requirement. Control systems similarly for operating different launch pads, different ISTRAC operations, MCF download stations. So many control systems are required. These are all the infrastructure point of view. Then come to ground support systems, a huge network of radars, huge network of, anyhow our friends are there from ISTRAC, they will dwell more on these issues. A huge requirement is there in this front. One of the ultra modern multi-object tracking radar, and 2 more such systems are going to come up in future, maybe another 2 or 3 years. Such kind of technology we have adopted and put it in operational. Many of the people do not know. This is one of its kind. Probably I think 3 countries, I hope, Madam, Subramanian Madam, only 3 countries have got this capability. India is one of the 3 countries. Yes, yes. See, mission computers, a huge collection of network. Probably launch pad is around 11 kilometers away from the control system. You just imagine how many converters are required, how much cable is required, how much fiber optic instruments are required, how much fiber optic cable is required, how many converters are required, how much data acquisition systems, how many repeaters, how many amplifiers. You just imagine to manage such a huge network, you cannot imagine. That's what I told you, no? You cannot imagine. Each and every facility would be around 5 to 6 kilometers apart. We have to interconnect them either through fiber optic network or through any means copper network. You just imagine what is the volume of infrastructure that is available in space industry, and further it creates business for you. And these are all the optical control systems. If you go to avionics packages, this is one listing has been some of my friend has given. A typical vehicle, how much, what are the different kinds of devices or elements that are there in each vehicle. These are all being procured, either getting converted or procured through MSMEs. Many of the things are imported, of course. Testing and qualification of each and everything is a Herculean process. Because many of the people are not coming forward for testing and evaluation of these equipments, ISRO is taking one step ahead for establishing the facilities and inviting them in O&M contract basis for qualifying these components for further use. So some of the facilities that are required, if any industry is coming forward for establishing the facilities, there is a procedure. URSC, SAC and VSSC, these are all the 3 major centers who are enlisting the vendors. You can register with them, then you will become a registered vendor with them, and you will start getting the business. So there are procedures. Our friends from the different centers, they are going to talk about how actually they are going to expect they are partner with the industries. These are all the just of the glimpses I am just making it, throwing to you for further discussion. Then electronics for stage separate system, navigation guidance, actuator packages, telemetry systems, signal conditioners, RF packages. You just imagine for a small RF cable, we are depending on foreign sources. Is it not time for us, because we talk very high going out, is it not time for us to think, why can't we develop even small MOSFETs, small sensors? We are depending on foreign sources. Why? Because first is performance. Second thing is we always concentrate on commercial aspects. The second thing is volumes. The third thing is infrastructure. Even to develop a small thing, probably a huge infrastructure is required. This is where I just even a couple of times when I made presentations to other electronic fora like this Iesa, Iesa, like Iesa, I told them, please join together. Take up the requirements with major industries, whoever is interested to come forward. Take up with ministries, become consortia, or become some kind of societies Go to the government, we will all help you. Such a kind of system, when it is not evolved, I don't think, in my limited experience, you call it as, but veterans are there, they can throw more light, maybe in the evening. Some veterans are there, they wanted to give some suggestions. Unless such kind of policies are coming out, it is not possible for India to become an electronic hub. The general requirements like the conditioned rooms, these are all minimum things. A few rooms, maybe clean rooms or something like that, it may be required for qualifying the systems. Those who have such kind of requirements, they can always come forward to have a discussion with us. The component management is another headache issue. Maybe a small package or a small device requires maybe hundreds and thousands of packages. The availability, even when a small resistor or small capacitor is not available, the entire production line get halted. So component management, qualified component management is a Herculean task for the electronic industry. So this you should have, because timeline is very important for us. Let's say when we say this particular launch is scheduled, whether it's commitment to the foreign satellite or commitment to the even our own satellite, the commitment is very important, timeline is very important. We should be as far as possible self-reliant, if not self-sufficient, to make all the basic components available. For that, a qualified component management system is a very essential for the success of the electronic industry, especially with space. See, if we take potential areas in the payload systems, you can take RF system, passive filters, antennas, digital systems, PCBs, PCB wiring and assembly, payload checkout systems, high-rel components, mechanical. This is a mosaic just I have given. These are all some of the groupings where the payload systems, we expect more industry participation. And if it go to the partnership, where this is another level of classification. If you see the component level, MMIC, S6, HMCs, then subsystem level, SSPAs, EPCs, transmitters, mode, so system level, and facilities what they require. This is only just for the information of the participant. I just summarized, which of course will be dwelt more by my succeeding speakers more. So how the industry participation is invited for ISRO. So this could be, I think this slide I have picked up from VSS, I think last time when they were presenting. So there could be participation mode, either build to specification or build to print. Now because why we are looking for build to specification is, some of the technologies are strategic. Maybe we may not be interested to reveal the information, such kind of things. Only once the industry parted with us and sailed with us, probably that also slowly we will share. We will transfer the technology, and to that extent, so many technology transfer agreements and technologies are available. Each and many industries, whenever I happen to meet and say in front of a couple of people, please visit our websites of different centers, LPSC, VSSC, URSC, SAC, Iesa. The technology transfer documents are available. Which kind of technology is ready for, even though maybe recently you might have come across, but old several technologies are there, which with a very nominal arrangement basis, these technologies we do offer, we do transfer to the people. Please, I request every one of you, please read our documents which are available in our portals and come forward to a better tie-up. And these are all the opportunities. I am just looking for end-to-end solutions, and the design front, maybe PCB manufacturing, such kind of things. Some of the examples only I picked up. These are all the facilities which we are looking for, some clean rooms, some certified manpower. Manpower is one of the crux of the issue. The attrition is so much in this nowadays scenario. If you train them, they will run away for higher jobs. But how to keep them? That is a challenge. These are all the challenges. These are all the real challenges one has to face. And tools and tackles. And now there are some facilities. Now they are open for the industries, even URSC or SAC or VSSC. That's what I said. No, initially we are building the infrastructure and making the vendors to use those facilities for building up the production. Such kind of opportunities you can always avail to start with. When once you picked up the technology and gained the confidence, then you can think of establishing your own infrastructure. I think this is the way we should jointly put our space program into anvil. Of course, we are comfortable with the industry, but we, as the volumes are picking up in the days to come, we look for major industries to take more interest, and medium class industry, medium level industries to support the major industries, and startups to come forward. For startups especially, there is a program ISRO is running, that is incubation centers. In the incubation centers, there is a tie-up with academic institutions. Around 6 incubation centers ISRO is opening up. The local talented people will approach the academia or that particular center. They come up with the technology. The startups will have an opportunity to prove that product, and ISRO is assuring to take it back to back after qualification. This is how the startups can take more lead. But I do not know if many startups are in software field or embedded systems field. Unless you come into the hardware side, more opportunities you will not see in space. Even though software, some opportunities are there. Very, very important thing is indigenization, which we are cracking unless we are it has become a buzzword everywhere, but I'm not able to get any breakthrough. Please concentrate on this indigenization of different components. They look very small. They look very small. If you come sit with us and understand the technologies with whatever available resources, what you have, infrastructure, what you have, you will definitely do, provided if you show some interest. Coming to the salient pieces of that national policy of electronics 2019, government is also throwing lot of interesting packages which will enable you people to come forward and pick it up. Don't look, my conclusion in this one is, don't look space as only business for you. Space should be, see, when you are serving, let us say 10,000 people or 2,500 people in a marriage, serving groom and bride is a different thing. You please categorize space in that area. Please, so that unless otherwise you become a passionate and you become a special, even though probably initially you may have to sacrifice some of your profits. But once you become a partner with us, because it is an issue, many people are not there, definitely the commercial part will be taken care. And you love working with us because we are passionate. Thanks a lot for being patient with me, and I hope looking for you in a better participation. Thank you.
Hello. Thank you, Sudhir. He has given extra time because he is the bridge between ISRO and industry. Now you quickly move on to any questions, any doubts are there? Anybody can ask. We have only 2 to 3 questions you can take because of short of time. Anybody have any doubts? That gentleman.
Hello. Thank you, sir, for that enlightenment. Yes, definitely the small companies, I mean, like us, definitely we don't mind, losing first time the profits. But is there any guarantee that you give us in writing that, okay, after you develop this prototype, you will get this order?
See, prototype development will come only along with the order. I don't think any government agency will work with you informally. And if at all you are qualified, no investment will be required for the development phase. As long as you are capable and you are confident of developing a particular device or anything, then only contract will be entered into. A prototype will be qualified, and for that qualified prototype, we will have a full-fledged support hand in hand. After that only it is an extension of guarantee definitely will be given. Any prototype development will be with contract only.
Okay, that's really great. But what I understand from the defense side is actually we develop a prototype and we get it qualified. Finally, again go for tendering. Probably again we have to be 10 rupees more. We will not get the order.
No, see, some of the areas what you have, I think it is a different mode of applications. Let us say if you come with a expression of interest, those who are interested to come forward, for that proving yourself, you may have to do some protocols, but I have not seen many contracts, I have not seen many contracts like this, very few contracts. But let us say if any prototype development has to be done, it will be done as qualifying procedure, not for, let us say, you develop and give it to us, we will accept it, after that we will forget it. I don't think I have seen any contract like this except very, very few.
Okay, thank you.
Thank you, sir. I'm asking this question on behalf of our members because after this event is over, they are going to shoot these questions to me. You have displayed fantastic opportunities for the industry, both foreign companies, local companies, MSMEs, all these companies put together. Now, is there any single agency at ISRO where they can come and register and tell that I can do this, I have these products? Because if I'm right, there are 9 different divisions across the country spread over the whole India, right? Now, there are so many components, there are so many divisions, it's a very complex jungle kind of thing. So if any SME or any company has some product, if they want to sell it, let us say that we are ready to invest on that, okay? Then whenever you give the order, we'll take it. But whom to contact? What is the system available for from registration to establishing or registering our products? If you can throw some light, it's really good.
Yeah. See, especially as I told you, in the electronics front, the 3 major centers are URSC, SAC and VSSC. There is a established procedure for empaneling a vendor. A qualified vendor will shoot, I think most likely, URSC, somebody must be throwing how actually the registration process is done. Anybody, Lakshmana Garu? Lakshmana Saman Garu? I think he has gone outside. They are going to be, see, actually the procedure is like this. When you are interested in any of the package, the best, Lakshmana Saman Garu, you are throwing how actually the empaneling of vendors will be done, like your registered vendors, in your covering in your presentation.
No, basically we are trying to cover an open invitation to everybody who is capable of the infrastructure. Who has the infrastructure, they can provide, always respond back. We'll review that, and in case we'll have one visit there to see the feasibility and capability of their production line. Based on that, we'll take a decision and move further.
Fine. So that is the answer, because once out of the 3 centers, if you register and become empanel vendor for one center, it is applicable for these 3 centers. That is one thing. Let us say as long as you are a new vendor. But let us say there is a process. The best way of entering into, in my experience I am telling you, the best way of entering into the business with ISRO is, please visit our e-procurement site, eprocure.isro.gov.in. As per the government mandate, we are publishing both limited tenders and public tenders. If the public tenders, if you happen to have it part of your product catalog, please apply for it. Please send a tender. That's how you become automatically a vendor with us. In case limited tender, if you happen to see and you didn't get the tender, you please write to head purchase in stores that you are capable of supplying this particular item, but still you didn't get the tender. First time they may not, it becomes an unsolicited offer, but next time they have to consider. At least you will get to know that this particular center has got a requirement which you can supply. You can always meet the people. But as far as the qualification procedure is concerned, as is told, an expression of interest will keep coming. I think once in 2 years or something like that, we publish. You may have to pay a little bit the alertness to see that this one. Otherwise, what we'll do, I'll just notify through Iesa also. They also can throw this particular advertisement whenever it comes to all the members and to all the participants. Thank you.
Thank you, Sudhir. Now moving on to next presentation, I invite Mr. Srimati Thenmoli, Executive Director, HA, for presentation.
Very good afternoon, ladies and gentlemen. Mr. Sudhir has made my job a little easier, so I can go a little faster because many of the issues of the electronics and avionics has already been covered. I come from HAL, and yeah, Hindustan Aeronautics Limited. I'll give you a little brief on the company and the products before we move on to the actual areas of technology and the problems which we are facing and what challenges, rather I would put it that way. So it started way back in 1940 by Sri Valchand Hirachand, and thereafter in 64 it became the public limited company as Hindustan Aeronautics. And thereafter we have now reached almost the 79th year of existence, and we are into um, rotary wing, fixed wing, manufacturing, design, development, manufacturing, repair overall. It's basically, you can see that it is spread across India, and we have 20 production centers and 11 R&D centers. Of course, these are the numbers of the aircraft and engines that have been produced and overall. So this is just a synopsis of what are the activities being done by HAL. We also do, apart from the aircraft, we also we have entered into UAVs along with DRDO, and some of the avionics, yes, we are also tying up with DRDO. We have done something for the missiles. I'll be covering it later. We also do the midlife upgrade for the aircraft, and our aerospace division in Bangalore does the manufacturing of the launch vehicles and the satellite center for the satellite structures. These again, it's a repeat, it's just a pictorial view. We also do accessories, the avionics, electrical, hydraulics, and other accessories, which I will be covering a little more detail. And through the transfer of technology products, the aircraft as well as other products from Russia and from Western origins, there is a lot of lesson we have learned, and there have been very good input for our indigenous development. Now these are some of the current programs, the manufacturing production which we'll be taking up, or it is undergoing. Sukhoi, as you all aware, Sukhoi 30, the light combat aircraft already under production, the transport aircraft, the Dornier 228, these are all for the military, and incidentally DO 228, that's a Dornier, is also getting into civil. We are actively discussing with the government for the UDAN program, and we are certifying the aircraft for civil, and we are also certifying some of the systems which will be going on to the aircraft and for civil certification. The advanced light helicopter known as the Dhruv, which in fact I have been working in this project for about more than 25 plus years, which has different configurations, is really doing very well, and we have future orders from the Navy and the Coast Guard and the Army, which are currently being taken up. The Cheetal and Chetak, of course, it is a licensed product from France, and it is still a wanted aircraft by Army and Air Force, especially Army at very high altitudes. These are the repair and overall program. Once you are done with the manufacturing, you have to keep the aircraft going. The life of the aircraft is about 30 years minimum, and the military, our customers wanted to extend the life of the aircraft for more than 20 plus years beyond its life. So structures will not be a problem, whereas the other components which go on to the aircraft, you have to do the necessary testing and probably some upgradation to keep it going. Apart from the platforms, the most important component in a platform would be the engines, for which we have been dependent always abroad. DRDO had made a valiant effort. I think they have reasonably have been successful, but then they could not, still are yet to come out with a product. They are working with, of course, other specialists again. We are also working looking towards indigenization, or rather develop indigenously a good enough engine for the trainer aircraft and for the rotor aircraft, trainer aircraft and rotary wing. These are some of the engines which are currently being used in various fighter aircraft. Now I'll come to some of the research and development initiatives. On the fixed wing side, I've already covered the light combat aircraft. We also have a Hindustan Turbo Trainer HTT-40, which will be shortly certified, maybe by the end of the year or little in the first quarter of next year. So this is basically a trainer aircraft. We are also getting into, this was a technology demonstrator the mini UAV was a technology demonstrator. We are also getting into fixed wing. We are interacting with DRDO for their program, and we are participating for the Rustum. And on the rotary wing side, there are many weight classes. I will cover it in detail later. On the engine side, we have initiated these two engines, one for the turbo shaft, that is for the rotary wing. The other one is for the trainer class of aircraft. And there are upgrades which are already done for the Jaguar fighter, as you are aware. And Hawk is another trainer. This is again which was produced here under license, and we have done some upgradation on this. Some of the specifics which are going on to the light combat aircraft. The current versions are already having the sensors and weapons, but we are adding to it with the advanced sensors, the Iesa radar, the active electronically scanned array radar, and the self-protection jammers and beyond visual range missile. Of course, all these are right now being imported. So we need to see how to get together. While we are trying out the LRE radar also in one of our LCA system aircraft, we need to really see how we can advance in these areas. The HTT-40, of course, it is meant for the training, and it's got tandem seating, 0-0 ejection, and various multifunction displays. Sorry. Coming to the rotary wing, it's one of the most difficult platforms to manage with. Noise and vibration are two partners which really put us in a lot of difficulty in many of the areas. So many people who have offered their systems to be put on the helicopter invariably will have to face initially a lot of stringent requirements as far as the environment and condition is concerned. So we started with a 5.5-ton ALH helicopter, and different versions have been given to Army, Air Force, Navy, Coast Guard. We have the light combat helicopter, which has been already certified, which will roll out into production in the coming years. About 15 numbers are expected for the initial order to Army and Air Force. The light utility helicopter is a 3-ton helicopter, which will be a substitute for the Cheetah and Chetak. Incidentally, all these are totally indigenously inbuilt at Hindustan Aeronautics Limited, of course with a lot of partners, private partners, and other public sector organization. A future is going to be a 12-ton class of helicopter, the Indian multi-role helicopter, which is again going to be the requirement for Navy, Air Force, and Army. These are the two engines. We have started this development. Of course, we have another couple of years to go before we get into the certification mode. So the one is the 25 kilonewton turbofan engine, and that's for the trainer aircraft, which will go into trainer aircraft. The 1200 kilowatt turbo shaft engine will be for suitable for the rotary aircraft. These some of the upgradation which we have carried out in Jaguar and the Hawk aircraft. So we have the open architecture, open system architecture, mission computers, smart multifunction displays, Iesa radar, LDP sensors, the mission computers, secure voice communication, and situational awareness systems. These are all the upgrades which has been made. On the Sukhoi, you're all aware that BrahMos has been integrated and tested. It's a great success on Sukhoi. We are also integrating the other missile from the DRDO, and we have been interacting with Air Force for cockpit modernization, avionics, and sensors. So HAL would like to take up this upgradation on Sukhoi. Already about 211 aircraft have been delivered, and they are all now coming up for the overall. So, and it has been more than 10 to 15 years since it has started. So we would like to look at the upgrade of this aircraft, fighter aircraft. The Mirage 2000 is another aircraft where we have collaborated with the OEM, that is Dassault, and certain sensors which are Indian specific, identified by the Air Force, has been integrated. These are some of the avionic and mission systems which have been developed indigenously, and I am very happy to say that there are many private partners in some of these systems, LRUs. The mission computer, the integrated avionic display systems, and the automatic flight control system. The cockpit displays, some of the interface systems, recorders, the flight data recorder, the attitude and heading reference system, the digital map generator. These are some of the other LRUs which go on to the aircraft. The communication system, that is the INCOM. These are all the names given to basically we and UHF range communication system. The identification system, very important system. We have tied up with Bell also, and CABS, CABS, that's a DRDO. So we have this system developed, and it goes as the airborne transponder. It works in the L band. We have the other utility systems, hydraulic engineering, electrical engine monitoring system, the data recorder, video data recorder. The radio proximity fuse is another system which goes on to the missiles. This we work along with DRDO. There are other engine control start system, the navigation systems which you normally see on an aircraft. These are again some of the mechanical and hydraulic systems which go on to various aircraft. These are all indigenously developed. This is just for the information. Electrical systems, power converters, fuel gauges, gauging system, wheels and brake system. We are proud to participate and provide the ISRO in these PSLV and GSLV. Major structures are built in HAL division, the aerospace division. And of course the challenges on the coatings and the material for such high temperatures. About 30% of our activities has been outsourced, where definitely the niche areas where we do not want, where we think that we need to involve is kept with us, whereas regular activities which can be taken up by the private partners. And I find that there are a lot of private vendors and startups who are coming up, who are very fast in absorbing the ideas and coming out with really quick solutions. So probably we will be able to increase this more. Now these are the current areas where we are getting support from the private partners: manufacturing, assemblies, harnesses, tooling, some of the design and development efforts, and various ground support equipment and ground handling equipment. Now these are the current projects which are getting into production. As I told you, the light combat helicopter, the turbo trainer, light utility helicopter. IMRH is in the inception stage. It will take about 6 to 7 years to come to production state. Upgrade, Hawk upgrade is expected. The HAL, that is the high altitude long endurance UAV, is something which we are going to take up, and we will be looking at for probably private partners to join us for some of the avionic systems to be developed as payloads. Now coming to the areas of interest. These are the areas which we are working on currently, and we would be looking at our private partners and the industry who is going to provide us components and support for the technology. So we have the artificial intelligence based system, a very common heading title I'm telling you, but these can be applied to many areas in the avionics for the aerospace. Simulators, of course, very useful. Mission sensors, for mission sensors and weapons. We are already in the process of developing, and we will be going into many more. High-speed data bus. So this is a time where we are looking at very fast data transaction between the various equipment, between aircraft to aircraft, aircraft to ground, and so on and so forth. So there are different varieties of requirement in this. So specifics you will be able to get only when you get into the discussion with the separate divisions. The lightweight material for avionics has always been a challenge because right now we are using aluminum alloys. So whenever we want the enclosure to be reduced, it's normally about 2 to 3 kgs for any typical LRU, which is half a TR. So we tell people to come up with material. We are working with some of the organizations, but what we find is the EMI EMC and the protection from the electromagnetic interference becomes an issue. It's a challenge. So this is one area we are also looking for some partners to develop so that we can increase the useful load on the aircraft and bring down our the weight of the avionic or any other computers. Voice-based interactive cockpit. This is already we have made this and we are trying it out. We would like to enhance the voice-based cockpit interactive cockpit systems. So we have a lot of ideas in the audio systems what can be done to reduce the pilot workload. Net-centric operation. This is a buzzword now. The Air Force or Navy or Army, basically the military forces, are looking at quick transfer of information, and not all platforms need to have the same type of sensors. They need not carry the same specialized sensors. So there will be a group of aircraft which will do this, and there are others who are in the ground below or elsewhere to take this information, analyze, transfer, and do whatever is required. So there you need this quick transfer. Smart, everybody wants to be smart, and you need to have a spectrum, frequency spectrum selected on the spot. Dynamic selection of frequency. This is another area we are also looking at. UAV swarms networking, yeah, similar data links between the UAVs, the communication and the data transfers. IMA based architecture, we are looking at more compact avionic systems or computers to be developed. In one package we would like to have all the specialized cards. Collision avoidance algorithm for sense and avoid system. This is one of the very important things. As it is, you would have been aware, you must be aware, the TCAS is on board the private, that is your commercial airlines. That is the terrain collision avoidance system, traffic collision avoidance system, sorry. So for the military also, people are looking at some kind of an avoidance, collision avoidance, not in the vertical aspect, but in the horizontal plane, in the azimuth plane also people are looking for. So this is something which will be required for both the UAVs, the swarm UAVs also. Of course, development of various algorithms using AI or otherwise for target detection, classification, target pattern estimation, etc. for applications. The order of the day is we are going smaller and smaller and more efficient, and of course people want lesser cost. The customers say this is too expensive, so the components are also very expensive. So we are looking at the partners for a solution, how we can optimize and reduce, with the high speed components, more efficient system, but still they want the cost to be lesser than their imported cost. System on chip, system on system, I mean these are all things which we are also looking at. In the only challenge in all these areas, okay, let me complete this and I'll tell you that. Hybrid radio altimeter is again a stealthy radio altimeter. Radio altimeter detects your height of the aircraft from the ground. And active antenna arrays, again in the L band we are looking for active arrays to be used as antennas. 4-beam Janus antenna is for a specific navigation system which works in the, these work in the L band. Of course, apart from these future topics, we also have systems which are already on board, which are going to be obsolete. We are looking for test rigs, automatic test rigs, high value items which are imported, which are leading to very high FE. Then items which are proprietary in nature, we are not able to, we are so dependent on one particular OEM or a vendor. We would like to diversify into one more or few more people who can help us out. There are many consumables, a plethora of consumables and raw materials are there. So you will find some of them in this, in the indigenization list, which will be useful for us to keep the aircraft going. The challenges, Mr. Sudhir had pointed out, Obsolescence in avionics, in electronics is of course a challenge to all of us. Form, fit and function, everybody wants a replacement without disturbing the PCB, the printed circuit board, without disturbing the, the size and volume of the enclosure. Even the interface, people don't want to change because it is very difficult in the aircraft scenario, if you see, to remove a loom, an electric loom, and to replace. It's a very, very difficult task because it is so snugly fitted. It's not easy. So it is but natural for the forces to, always want a solution so that they don't have to do the extra work. Only let's replace the equipment, and it should be a hi-fi equipment as compared to what was there earlier. So that is a big challenge. Supply chain management, yes, it's an issue. Technology changes. The life of building an aircraft is not going to be in a year or a two. It's going to be, the gestation period is going to be nothing less than 5 to 10 years. And thereafter it comes for production. And once it comes for production, it continues, and then it comes, of course, the cycle comes to the ROH, that is a repair overall, till it reaches there. But by the time you design and build, your technology is already changing. So there's always an effort to upgrade without extra money, extra cost. But time is cost, time is money. So we are always at a crossroad there. As I told you, cost, weight and size matters a lot in an aircraft. Stringent quality controls, not as stringent as space, it's a different game altogether. But here, yes, in a rotary wing, you have additional concerns of vibration and noise. And talent retention, already spoken of. And you have to support the product for minimum of 20 to 30 years. Now, we have been supporting the MSMEs and startups in different ways. And we also offer the facilities, whatever we have, the test facilities for proving them for the military environment. Private industries who are interested to use this, they can always log into these websites to find out what are the procedures and what can be done. But this is again the request that we had made this in the CPSC conclave. That is public sector enterprises. There was a conclave, and this issue of the test setup infrastructure, because this costs really crores and crores of rupees. Not everybody in the country should be owning it and having it and not utilizing it, because these are used for only certification or a qualification. So we brought out this and said that private industries are, or private partners are facing this problem, because not one under the umbrella, or one umbrella and everything is not available. So I think some action is being taken up, and I will be really happy to see that if this is taken up, all of us will be benefited. Last but not the least, this ALH, apart from doing yeoman service to the military, this has been deployed. This is a reality. This has been deployed in as a savior in various incidences, mishaps. And it has really done a great relief operation. So I'm really proud to be in this field of aerospace, and definitely we can work out together, the private and the public sector. We are making ways to see how to minimize. Somebody pointed out about you make a prototype and then you're not considered, and you select, you again send an RFI, RFP. This issue has been deliberated time and again, and we are getting into long-term business agreement. And in case there are more than one partner who is capable of giving the system, we are also trying to share. If it's in a production case, it can be shared as 60-40. That is also there. It's something allowed, we have brought into the system. We are taking your feedback and trying to see how much more we can bring in the participation of startups and the private partners, so that we quicken the pace of getting good niche technologies, and we become the integrator. So that's the idea behind all this, and I think together we can make a more formidable India. Thank you very much.
Thank you, madam. Quickly moving on to the question answer session. Any questions?
Okay, thank you.
Madam, I am Ramar Sundaram from V Technologies, Bangalore.
Yes, sir.
We like to work with HAL for their product requirement. For long-term perspective, we are ready to invest any amount of money,
Okay.
provided the product visibility should be there. What is my previous experience for indigenization? 2-3 years worked, end of the result, nothing, no support from HAL. I'm
Which
selling
is a division? Which is a division you?
overall division. Okay. Now we are open to support to go for any product for long-term perspective. But there is a whom to be contacted, right person, because n number of people are sitting in HAL.
Sir, my suggestion to you is there is a site I had given. If you want, I will.
No,
give it
site
to
I
you.
know.
Indigenization site.
Yeah.
So depending on what is the component, you have to contact
No,
the respective
I want to
persons.
understand from you, your end, HAL, what is the requirement? You need the industry partnership
Correct.
for anything. If you are having visibility straight away, you can say,
Sir,
then I
it
will
is
come
like
with.
this. It is like this. HL has got 20 production divisions and 11 R&D centers. There are the requirements are diverse. So I won't be able to tell you that I want this, this.
Even if not today, after a month or after 2 months, I will give you my business card.
Okay.
We are ready to work
Please
with
give me your
HAL.
business card.
Yeah.
And what is your specialization and which area you would like to take up?
Already last 7 years we are associated with the ISRO
Okay.
for various space grade motors and other things.
Okay.
So it is all proven. So we like to, I am trying to make attempt to a number of, because it is like ocean HAL.
True.
Because
True.
to get a crack.
I agree with you.
So-
Sir, it's like this. You may have capabilities. Now, what is the requirement from the overall division or what? That is something which you need to understand and both have to meet.
I am in the other perspective, because for HAL, what it is looking for industry people to participate.
Okay, I will still suggest you go look at the site, but in any case, you give me your card and let me know what exactly you're looking for, what you want to offer. That should be something which
We
is
want to
acceptable.
design and develop products for the your defense requirement or the space.
Sorry for the
It's
breaking.
very-
I
very-
think off the
very-
dais,
very
can you
broad.
discuss these things?
Yes, I think so. Right,
Sorry,
thank
sorry.
you.
Thank you.
Can I ask a small question, ma'am? Okay, because I got the
Oh,
mic.
yeah.
Yeah, because thank you for mentioning my last question for that vendor giving some 60-40 model. So actually, it's just a general knowledge question. I try to understand, because one time you were saying that by the time you really design, the technology is obsoleting, right? I mean, most of the cases. Now you, and again in the another slide you said it takes 2 years to get an idea, and 5 to 10 years to develop the
aircraft.
design,
An aircraft.
and you want 30 years to be the you want the safeguard.
So 30 years is a life.
How is it possible actually?
I'll tell you. I'm not talking about the avionics being there for 30 years. See, invariably 15 to 20 years they use this. It is, see, by the time you test the system and then you put it on the aircraft, definitely it takes about 5 years. You conceive a system, prove it on the aircraft, and it goes to production. It's about 5 to 6 years time. And thereafter the users, the customers do not want to change immediately. So what we do is, form, fit and function, we replace the same system with an upgraded avionics, but at the same cost. So that's what I was trying to tell you. The challenge is replacing a higher or more efficient system at the same cost. Most of the time this is what they want, because they don't want to change anything on the aircraft. So avionic replacement happens, but you cannot change something like engine or the hydraulic system or some of the major fuel systems. These are something which you cannot just throw away. So even though technology will not change in those areas so rapidly like electronics. That's what I was trying to tell you.
Okay, thank you.
Right.
Thank you, madam.
Thank you.
Moving on to next presentation.